So today I thought I would do a little bit of baking in the kitchen, and we're baking battery management systems today. So these are my own design. These are specifically for the LEV40 cells found inside the Mitsubishi Outlander plug-in hybrid. So my plan is just to make these for all the different cells that you can get, and I might make a generic board as well. So these can be made for lithium ion and LiPo 4. So I'll work with all the cells. So what I'm going to do today is solder them, and I'm soldering them in the oven, and I'll show you how to do that. First, preheat the oven to 200, then place the board inside. So that's inside now, and we're going to wait 1.5 minutes. So after the 1.5 minute mark, what we'll do is we'll turn the heat up all the way. In the case of this oven, that's 256, but it probably won't even reach that temperature anyway. So this is just a stage where we're sort of like heat soaking everything, letting everything equalise in temperature. So I'll just zoom in to try and show you what the solder paste looks like and everything. There we go. And as you can see, the solder hasn't gone off yet, which is to be expected. It'll take about 2 minutes until that actually starts going off, I reckon. So I'm just going to actually go through the whole process. I'm not even going to pause the video, so I might bore you a bit, unfortunately. But I just want to try and show the whole process and give you an accurate idea of timings as best as I can. So I'll be getting ready to just turn it up to full soon. I reckon about now. So here we go, heat's on full, and I'm just looking as best I can to see when the solder starts reflowing, at which point you see the solder start melting. Just count 20 seconds and then take the board out immediately and set it down. Like, you could set it down in fiberglass wool perhaps, or some sort of heat mat to cool down. Don't cool it down too quickly. It's best to put it on some sort of something which is an insulator. So things are getting nice and hot now, and we're just waiting for that solder to start reflowing. Okay, it's begun. Right, that's 20 seconds. Let's get that out there promptly, and I'm just placing it on top of this plumber's soldering mat, and that should just cool down. So let's inspect the quality of the soldering. That's how it's looking. Can't see any immediately obvious defects just now. There are actually some design defects with these. These are prototypes, so these particular ones are not getting sold. These are for my own experimentation and testing. So there's a wrong connection I made down there, so it's just meant to be connected to something else. So I'm actually able to put a bridge wire on that, and as well some of the holes are in the wrong place too. So we'll need to sort that also. So this is how it's meant to look. This is it sitting on top of the cell, and as you can see, I've designed it around the cell as best I could, but just these holes need to be slightly bigger in a different position. But otherwise, it's pretty good. And I've chosen through-hole resistors because the boards will just overheat during balancing. With through-hole resistors, I could get more balancing current. But yeah. I've got some of these already working, and I'm happy with it so far. This is based on a design that I've actually had going for a couple of years now, just because I cannot get parts for my motor controller I'm developing. I've just decided to focus on this just now, and I should be able to make absolutely loads of these if the demand is there. And if anyone wants some of these made for them, then you could probably just send me exact designs of the top of the cell so that I could make these to fit. And it'll be fairly expensive. I reckon my price point just now is £4 to £5 per board, so it's scalable, so you don't have to buy a whole expensive battery management system if your battery bank has just got like 4 cells in it. It's scalable. It's targeted for lower voltage systems, like your 24 volt systems found in your or 48 volt systems for solar power. That's my intended application, although you could probably take this up to 400 volts if you want. That's on you, however. They are isolated, so they do output fault signals over an isolated connection, so as you can see, we've got quite a large isolation barrier there, so it would probably withstand, I would almost certainly withstand 400 volts across it, because as you can imagine, as you're getting higher up in the bank in your string, you've got higher voltages, and obviously there's a bit more of a danger there, hence that isolation. So to work these, you just supply them with 5 volts to turn them on, and then if anything goes wrong, it actually outputs a fault signal. So I've developed a central unit these connect to. Yeah, I'm very happy with the soldering, and please let me know if you want some of these, and once I'm satisfied with this design, I can start making these for people and finally get this business on the road.